really bad one, but we'll call it okay. No judgment. It's a scientific representation right here. All right, somebody, can you tell me, please, what do the magnetic field lines of the Earth look like? Go, Haley. Say that one more time.
They're like coming out of the center and they're kind of going around it.
And where would they come out of where and go into where?
The other side.
So like from here out and around?
No, the other, like top, and then it goes around.
Okay, so can you use some scientific technical language there?
No.
Can somebody else help her out? Where do they come from? The poles, right? No, it's okay. That's why we're working together, right? Learning as a community. So they're coming out of one pole, right, and going into the other pole. That's that whole thing that we learned in magnetism. We need to write that down. So the magnetic field lines are going to come out of one pole and into another pole. Okay? And the strength of the field is bigger when it's closer. Okay? And it's fairly symmetrical. And the field lines look a lot like they did as if there was a bar magnet inside of the Earth. Right? We remember last week that we saw that bar magnet. Something like that, right? Okay, we saw those field lines on the with those iron filings, and it looks something like this. The Earth's magnetic field looks something like this as well. Okay? That's awesome. That's awesome. All right, what'd you say for the second part? What creates the magnetic field inside the Earth? First question, is there a bar magnet sitting in the middle of the Earth? No. Yay for getting rid of that misconception if you had it. Sweet. There is no bar magnet in the middle of the Earth, but something has to create these field lines, these red lines that we've got here. We'll go here and then we'll come back here. Go.
There's iron and nickel inside the core, which is magnetic.
There's iron and nickel in the core. And then you said something else.
And it's magnetic.
And it's magnetic, yeah. And it's kind of funny, and there's a lot of physics that goes into this. So in, 11th or 12th or even 10th grade, if you really want to, you can take physics with me, and we'll talk about how and why this happens. But those metals move around, and as they move around, they create a magnetic field. Through their movement. Question for you. Is the magnetic field of the Earth static? Static means it doesn't change. It doesn't move.
No.
It's not static? It's what you say? It's dynamic?
Yeah.
Dynamic is the opposite of static. How do you know that it's not static?
Well, because it moves. Yeah,
That's in the core, right? That's the iron and nickel have to move. My question is, have the magnetic field lines around the Earth always looked like this?
No.
That's what I really want to know. Yeah?
I would say no, because the Earth is always like moving and stuff, and changing inside.
Okay.
So it's never like just one.
always
One. Yeah.
Okay. So how much do you think they change? Anybody know? They kind of wibble and wobble a little bit? What were you going to say? Oh, come on, Jacob. What were you going to say?
That I don't know like how often it occurs, but sometimes they'll poles flip.
They do, yes, and that's exactly what I was hoping that somebody might know. It's weird, and that's what all of today is about, right? So here's the weird thing. It's like, what? Yeah, I had this conversation with my mother-in-law and my sister-in-law about, 8 years ago over Thanksgiving dinner. They're like, they must have heard something like a story on the news. Are the poles gonna flip? It's like, yeah. What? It's like, yeah, it happens. Now, it hasn't happened in a long time in our lifetime, but it is bound to happen again, and we're going to talk about it. Yeah.
Does that mean Santa has to move?
I don't know. It's a good question, right? That's for a whole different conversation. I do want to show you hold on just one second. I want to show you some computer models of what the magnetic field looks like right now, okay? As well as some other pieces. Gracie, you had a question.
Like, how are we gonna know that it moves?
That is a super good question. How do we know that it moves? It's like you guys are like chomping at the bit, so excited about finding out. Can I show you the picture first? Is it a serious question or is it a question about a holiday?
No, it's a question about the sphere.
About what?
I just want to say that I wasn't laughing at the sphere. I was laughing at the fact that you said, "Oh, this is going to be simple," and you commented like 3 years.
Oh, gotcha. No, it's okay. I didn't take it personally. It's all good. All right. So I want to show you this picture. So the magnetic field lines right now look something like this. They're already a little bit complicated. Our pretty picture that we drew is not quite that simple, but you can see that there are a bunch of, like the yellow stuff, that's coming out of the north hemisphere, right? The northern hemisphere. These blue lines are coming out of the south. So that we can kind of assume that it's like the North Pole up here, right? And the South Pole down here. Does that kind of make sense? So in our picture, that these lines would be kind of one colored up here and the other colored down here. That's just how they did it in that graph. The reason that it's really interesting that I like that they have yellow and blue is because at some time, it's already kind of starting to happen. The magnetic field lines that are pretty well organized are going to do this. What? Like that's messed up. So don't get your compass out and go out into the woods and start that's gonna be messed up, right? You're just gonna walk in it. Who knows? That the magnetic field lines do something kind of crazy town, but then later, what does this look like? Can you compare this one to the first one? It's flipped. That's weird, right? That's weird. So that's one kind of interesting thing. So then I was talking to my in-laws, right? And they were like, what? How's this going to affect things? You're going to find out today. And does this happen a lot? And I was like, actually, yeah, it really does. And I found this graph I'm just going to kind of like look at it. And there's one of the activities that you could do today looks at this. And we're not going to get into details, but this is the magnetic polarity of the Earth's magnetic field. Polarity means north is in the north versus north is in the south. That's all it is. Does that make sense? Okay. North is at the top, north is at the bottom. The black boxes, it is, but I want to explain it to you. Do you remember? Oh, I didn't show. So I've told you before, graph reading is all about science, right? Do I expect that in 25 years when I see you on the ped mall walking around that you're going to be able to recite all of these details to me? No. But I do expect that you have this great understanding of kind of like how to get knowledge. If you were presented with a picture like this, you don't go run screaming like you would from a bear. You say, let me see what this says, right? So let me explain. Magnetic polarity, okay, that's north and south of the Earth's magnetic field in the past, okay? This is the past 160 million years. 160 million years. So let's zoom in a little bit here. Whoa. So this is today. This is today right here. Right here. This is like the present. This is where we've been. This is what they're calling normal. Why do they call it normal?
Because this is what's happening right now.
It's because it's what we know, right? Yeah. Think about like humans have not been around very long, right? In the Earth's history. This is all we know. But if you look, I'm just looking at this one over here on the right side. Okay. It switched. You with me there? It has switched a lot of times over the Earth's history.
And why stayed so?
That's a really good question. We don't know. It's an open question in science. Take a look over here too. So this was the thing that Beth was kind of getting freaked out about, like, whoa, that's really scary. So this right here is just a zoomed in part of what's way up here. Do you see that? This is the rest of Earth's history. Look at this. From here to here. It stayed the same. It stayed normal for all of that time. But then if you look down here a little bit further, it went back and forth and back and forth and back and forth and back and forth. Right? Geologists don't really understand why. They're still trying to figure out open questions in science. That means that there are jobs for you to have, right? Okay. These people are still trying to figure this out right now. So it's kind of cool. All right. So I just wanted to share that with you just so that you were aware that the magnetic field of the Earth is not constant. Okay. The other piece of it from a geology perspective is that we can use that knowledge to understand more about the Earth. Do you remember in our magnetism stuff, the very, very last experiment that we did, we had that rock that the compass was able to move from the rock. Do you remember that?
Yes.
Yeah. So rocks have magnets in them. They can be magnetized. Okay? So they can use that. All right, we got to get started. So I'm going to explain what's going to happen. How many of you remember back to when you were in elementary school, like kindergarten, first grade? Yeah. When you were in kindergarten and first grade, did your teachers sit you down like this and talk at you for 45 minutes at a time?
No.
Heck no, that would never have worked, would it? No. Instead, and different schools do different things, but probably for most of you, you went kind of from one thing to another, and it was a little bit self-paced, and it was a little bit like you get to choose what you want. Like maybe now you're going to go to the math center, and then you're going to go to the reading center. You remember this kind of experience?
Yeah.
That's what our day today is going to look like, okay? I need you to listen because I need to explain this because as high school freshmen and sophomores, you have been indoctrinated to just do exactly what you're told. And now what I'm saying today is that within reason, you need to follow what you're interested in. I have 6 stations that you're going to have the opportunity to go to, okay? You'll have 10 minutes at each of 3 stations or so. We'll see how we do. We may need to cut it back just a little bit, maybe 7 minutes at each station, okay? If you finish a station early, you may move on to another one, but you need to be engaged in earth science work for the whole time. Okay, so this means not on your phone. It means not talking to your friends about going to the beauty shop yesterday. It means not talking about what you're going to eat for lunch. Whatever it is, we're not talking about it. We're doing earth science. Does that make sense? Okay, second piece that's important to know. We will have a quiz tomorrow covering the big ideas from today. It does not matter which of these stations you go to. They all are covering the same big ideas. So by doing 3 of them, you will certainly have gotten all of the information. Does that make sense? Okay. So there are 6 of them. We may, you know what? I'm gonna adjust a little bit. We're gonna do, let's see. We're gonna do 4 stations, and we're gonna do 2 of them today and 2 of them tomorrow at the beginning of the period. I think that's gonna be better rather than rushing through. Okay. So just FYI, we're gonna do 4 different stations. 10 minutes of each today, and then we'll do 2 of them tomorrow. Does that sound okay? Okay, so the 6 stations that we have. Station number 1, so I put little labels all the way around the room in pink. Do you see those little pink labels? Okay, they correspond with each of these. Number 1, station number 1, everybody has to do. But we're going to do it kind of in an organized fashion, so I'll explain that one in a minute. Station 2 is located over there behind Beth. It's about seafloor spreading. So we know that the crust of the earth moves, okay? And there is new stuff being created. So that one's a hands-on activity with some questions to answer. Table 3 is the one in the corner back there. This one has to do with that graph that I just showed you, okay? It's kind of a graph reading activity to kind of get a sense of what's going on in those pole reversals. Station 4, which is the table where Livy's sitting at, okay, has a creative writing opportunity. So if that's something that you're interested in, if you'd like to do something that's a little more creative instead of just answering questions, that would be a great place for you to go. Station 5 is over there back behind Hayden. It's the one right there. Okay. It's a short video and then some questions to answer. Station 6 is way over in the corner back there. And that one is it's an article to read and some questions to answer. Okay. So there are lots of different kinds of choices of things. You need to make decisions based on you. So what I would like you to do right now on your paper somewhere is to list the top 4 that you want to do. Okay?
Yours too.
That is going to be one of them. So number 1 will be, so you can write down the other 3 that you want to do.
That's that one.
3 and everybody's going to do 1, and then you get to pick 3 of these 5. Okay? Does that make sense? So go ahead and write down so that you have a plan. You need to pick, so everybody will do station 1 at some point in the next day or 2. And then you're going to do 3 of these 5. So you can pick 2 that you don't want to do. And that's fine. Okay? And I'm not going to grade you on which ones you choose, but I want you to make a choice right now. Not based on what Hayden is doing. Okay? Not based on what Liz is doing, but what you want to do. What you think will be the most interesting. Okay? What's that? No, I want you to keep it because you need to know where you're going. Okay? All right. What we're going to do right now is we're going to count off by 4s so that I know who's coming over to station 1 with me to start. Does that make sense?
All right.
And then we're going to start a 10-minute timer. Some of you are going to be, so listen carefully. So if you are a 1, you're going to come over with me and do station 1 with me first. If you are a 2 or a 3 or a 4, you're going to pick a station. All of the papers are there, so you're just going to pick the one that you want, okay? And do it. Then, after 10 minutes, we'll switch. You may go get a drink. Any other questions that you have right now?
No, ma'am.
Does this make sense? Do you think we can handle this?
I think so.
Fantastic. Okay. So we're going to start here to count off by 4s. Go.
1, 2, 3, 4.
Hannah's going to be a 1. Okay. So if you are a 1, you're going to come with me over there. If you are a 2, a 3, or a 4, find one of the stations that you're interested in and get started.